So let's take an example of a distribution, a normal distribution where mu is the mean and p is a value. We are taking a deviation from mu. So let's say the value is p. So mu plus p and mu minus p. The probability for mu plus p, p less than mu and p more than mu, they both will have exactly the same probability. However, for an exact value, the probability is 0. Like I have explained in my last video. In a normal distribution or in any probability density function, the probability for any exact or discrete value is 0. But normal distribution is an act, but we are not talking about discrete and continuous variables. So we are talking about that. We are talking about symmetric. We are talking about symmetric distribution. So if you can observe from the graph, f mu minus p is equals to f of mu plus p. Okay, and here mu is clearly the line of symmetry, right? So the distribution where such an equation is applicable is symmetric distribution. Right, and f here is the probability density function, of course. Now, for a symmetric distribution, there is an equal probability for a random variable equidistant from the line of symmetry. That's what makes a distribution symmetric, because the mass of distribution is equal on both the sides, right? But let's say if the distribution is slightly concentrated on the right hand side or slightly concentrated on the left hand side, okay, then such distributions are called skewed distributions, right? So this one is right, so this one we'll call as so this distribution which is slightly concentrated on the right hand side is left skewed distribution, and this distribution which is slightly concentrated on the left hand side is left skewed distribution. So skewness is the measure of skewness and the measure of, so distribution is skewed, it cannot be symmetric. So this is, and so here the reason for asymmetry is skewedness. So here the reason for asymmetry is skewness, right? Which is the measure of asymmetry of probability distribution of a real random variable. Which I can also write in terms of equations for a given value for a given value xi, which I can also write in terms of equations for a given random variable equals to 1 by n sigma from I to n xi minus x bar, where x bar is the mean, upon 1 upon n minus 1 sigma I sigma from I is equals to 1 to n xi minus x bar whole square, and this entire 2 to the power 3 by 2. So this is an expression for skewness, right, in terms of equations and for any random variable xi. Now